A deck of cards is dealt out. What is the chance that the first ace occurs on the 13th card? Well, we probably have some good intuition for this, but let's work it out formally. Let AI be the event that the ith card is an ace. So the ith card is an ace. So what is the event that we're looking at here? Well, we're looking at the probability of A1 complement, right? The first card isn't an ace, and A2 complement all the way down. So and dot 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 and A12 complement and A13. So we get the ace on the 13th card. So what we're going to do here is we are going to use our multiplication rule. So let's work this out for a few simpler cases first. What's the probability that the second card is an ace? So let's say second card, second. Well, that's A1 complement and A2. These events are clearly not independent, since if I didn't get an ace on the first card, I have a higher chance of getting an ace on the second card. So let's just write this out. This is the probability of A2 given A1 complement times the probability of A1 complement. And we can work these out. So the probability I don't get an ace is 12 over 13 for the first card. And then if I didn't get an ace, then the probability of getting an ace, there are 4 aces, and there are 51 cards left in the deck. How about for the third card? For the third card, this is P of A1 complement and A2 complement and A3. So what do? We'll treat this as our combined event, so we can work on this and this intersection first. So we have the probability of A2 complement and A3 given A1 complement times the probability of A1 complement. Now we need to expand this further. So remember that we can do the same multiplication rule we did with unconditional probabilities with conditional probabilities. And so this stays untouched. It's still going to be there. So let's take this, and then we have probability of A3 given A1 complement and A2 complement. Now we have to take out this, so we have the probability of A2 complement given A1 complement times the probability of A1 complement. And this is the same as before. This is 12 over 13. 12 over 13. Now the probability I don't get an ace, given that I didn't get an ace before, well, there's 47 over 51. And then here, I have 4 aces, and then I have 50 cards left. So that's 4 over 50, or 2 over 25. So I just multiply all of these together. So you see there's going to be a pattern here, and we can just, and you probably see how to do it by now. So we can write it out as just the probability of A13 given that none of them have been aces so far. A1 complement intersection A12 complement times the probability of a 12 complement given a 1 complement and down to intersection a 11 complement, and so on, right? So it's just what's the we just sequentially we draw, we say what's the probability that I didn't get an ace given that the past card wasn't an ace, what's the probability I didn't get an ace given that the last 2 cards were on an ace, and so on until I get to the 13th card and say what is the probability that I get an ace given that the previous 12 cards were not aces. So we can think of this kind of like a tree if you want. So this is ace, this is ace complement, do it again, ace, ace complement, ace, ace complement, and so on. So the probability of going down this branch changes as the ratio of aces in the deck is fewer as we start taking out the non-ace cards. So now all we have to do is say, well, on the first draw, the probability I don't get an ace, so that's 48 over 52. Then there's 47 over 51 left, and 46 over 50, and so on. And we're going to do this 12 times until we end up at 37 over 41, and then finally 4 over 40, because that's how many cards are left on the 13th draw. We've taken 12 out of the deck. And you can just multiply these together and you get what you want. And you can double check that each of these terms is indeed the probability of not getting an ace, given that the previous however many cards have not been aces as well.